Alright, so in order to find the slope of a curve at y equals f of x at a point of p of a comma f of a, which is the next part in your notes of the number, we're basically going to be looking at something like in this gray box, except the only difference is that I have an a plus h instead of an f of x sitting here, and I still have the f of a sitting here. That's the only difference. It's the same thing. It's using function notation. It'll be okay. But I just want to show you guys something real quick. Alright. So this whole idea of a tangent line is basically, as I am trying to get closer and closer and closer to this point, I am basically just trying to see what this value is as I overlap. This is this whole idea of a tangent line. That's it. Okay, so in order to get this equation of a tangent line, we just move the 2 points from secant lines so close together that they're basically the same point, and we do this by finding our favorite thing, the limit, as in our definition, as h goes to 0. So let's head back over to the notes. We're just waiting for this point to become the same. So if I was to drag this particular point closer and closer and closer and closer and closer and closer and closer, that tangent line should get closer. Alright, so it says draw at least 3 more secant lines using the point P each time. So I could draw a secant line that passes through these 2 points. Alright, I could use a secant line here and here. Wow, my blue and the printer blue looks about the same. And I could use a secant line that's about here. Alright, so as h approaches 0, the slope of the secant line approaches the slope of the tangent line. Alright, that's about it. And tangent lines should just touch the curve at one particular point, as we saw with the little slidey slide. Alright, it will go to just being 1 point. So in order to find the slope of the curve, I'm always looking for a constant, so the slope of the curve is just constantly changing. So think of a curve as a roller coaster that we are riding, even though Miss Schuster hates roller coasters. If you are, for some reason, the track will just disappear. You will go flying off in the direction that you were traveling in the last instant before that track disappeared, which is extremely unfortunate. Let's avoid final destination, please. The direction you flew off would be the slope of the curve at that particular point. Use the slope of the secant line from the last example. We have the following definition, which is the same one that they had on the interwebs. It's just instead of f of x here, whoa, hello, don't care about my connection. Alright, instead of just f of x sitting here, they have f of a plus h, which is the more technical definition. Alright, which is what I was talking about on the other page. Alright, so this particular piece right here is called a difference quotient. Is that actually the most important thing? No, but our goal is to simplify this magical difference quotient and then evaluate it as at h approaches 0. Yay, limits. It's not like we haven't been dealing with limits for this almost entire chapter. Alright, so the difference quotient is just simplified when we have canceled the h in the denominator algebraically the correct way. Alright, so just trying to find the slope, which is why it's represented by m still. Just going to plug in 0 for h in the end. Right now, if we were to plug in 0 for h, we get a 0 in the denominator, brain goes boom, it's a bad day. Alright. Anything else? Alright, so finding an equation of a tangent line, we need to find point P and a slope. So as the limit as h goes 0 is the difference quotient, the slope might not exist because the limit doesn't exist. Discontinuities, vertical asymptotes, oscillating functions, or because the tangent line has a vertical slope, which is a fun trip. Alright, so for a tangent line that exists but has no slope, the definition doesn't quite fit. So to cover the possibility of a vertical tangent line, we can use the following definition. So the limit as h goes to 0 of f of a plus h minus f of a all over h is equal to positive or negative infinity. The vertical line x equals a is a vertical tangent line with the graph equals f. So what types of graphs would have vertical tangent lines? Well, we can think of, what's a good one? F of x is equal to the cube root of x, maybe? I think you can use almost any odd-rooted function other than, yeah, you should be able to. Alright, so if you're riding a roller coaster, you're like, wee, right here, having a grand old time. But then once you get to about here, you're like, ah, crap, because this particular bit is actually a lot rougher than it seems. So let me draw that a little bit more accurately. Alright, so that's a little bit more accurate. So you're having a grand old time here, and then you're like, oh crap, you're about to hit a brick wall here, and that's not a good time. So that's why that happens. Alright, so before we start using this definition, be comfortable with the function f of a plus h. Please don't let the algebra 2 kill you in calculus, please. This is just function notation. This is all this is. So basically, anywhere in the function that we see in x, we are either going to replace it with an a, or we are going to replace it with an a plus h. Actually, we're going to do it twice with both. So f of a, well, a replaced this x, so guess what? Anywhere I see an x, I'm going to replace it with an a, so I get 1 over a. And then f of a plus h, again, this entire quantity, replaced this x, so anywhere that I see an x, I'm going to replace it with an a plus h. No matter how many x's there are, we're going to replace it with a plus h. So in this case, there's just 1. Alright, so that's not so bad. On the second one, we've got the same type of deal, f of a. So f of a, again, replaced my x. So anywhere that I see an x, I'm going to replace it with an a. So that's just a squared minus 4a. And then f of a plus h, even though it's an entire quantity, this entire quantity, just replace this little tiny x. So anywhere that I see an x, I have to replace it with the entire quantity of a plus h, no matter where it's at in the equation. So I get a plus h quantity squared minus 4a plus h. It should be a squared plus 2ah plus h squared minus 4a minus 4h. Alright. And then last but not least, I should have f of x equal to the square root of 4x plus 1. What is f of a? What is f of a plus h? So again, replace your x with a to get f of a. So I should get the square root of 4a plus 1. F of a plus h should give me, I replace the entire quantity of a plus h from x. So I need to have the square root of 4 times a plus h plus 1. Still from the original function. Yay. Alright, so that should equal the square root of 4a plus 4h plus 1, all underneath there. Alright, so finally, yeah, that's about it for those two examples.